In this session, we are looking at question 16 of 2020 HSC Mathematics Extension 2. Two masses 2m kilogram and 4m kilogram are attached by a light string. The string is placed over a smooth pulley as shown. The two masses are at rest before being released, and v is the velocity of the larger mass at time t seconds after they are released. The force due to air resistance on each mass has magnitude kV, where k is a positive constant. Show that dv over dt is equal to gm minus kv over 3m. Okay, so this is like two masses going connected by a string which goes to a frictionless pulley, and this string is not extensible, so we can assume that, and it's got zero mass, and we can assume that the two masses have the same velocity, even if they are talking about the velocity of the larger mass. For any mechanical question, as always, our starting point is Newton's second law, F equal to ma. What we do, we draw the free body diagram for the larger mass, 4m. This is affected by three different forces. One is its weight, which is 4mg, and it's downwards, mass times acceleration due to gravity. The other one is the tension of the string, which is trying to stop it from moving, so it's upwards. And the third one is the resistance, which is always against motion again, so kV, as they have told us. Okay, so if I write the net force for that, I start with the force which is causing acceleration, which is 4mg, minus the forces which are resisting that, kV minus t, equal to mass times acceleration. Its mass is 4m, and its acceleration is dv on dt. That is for the first larger mass. For the second or the smaller mass, 2m, we have again three forces. One is its weight, which is 2mg acting downwards, the tension in the string, which is upwards, and because this is moving up, the resistance will be again is this velocity, which is kv downwards. Now again we start with the force causing the acceleration, which is t, minus the forces which are opposing that, which is kV, and minus and 2mg. So t minus kV minus 2mg equal to its mass 2m times its acceleration dv on dt. So what we do here, we make t the subject from this equation and use it in the first equation. That will give us 4mg minus kV, and then t is kV plus 2mg plus 2m dv on dt. That is the left-hand side of this equation with t replaced with from this equation, equal to 4m dv on dt. All right. Now we just simplify this. 4mg minus 2mg is 2mg, minus kv is minus 2kv, and then we can take this minus 2m dv on dt to the other side to become plus 2m dv on dt, and we get 6m dv on dt. 2mg minus 2k is equal to 6m dv on dt, and divide both sides by 2, you get mg minus kv is equal to 3m dv on dt, and from here make dv on dt the subject, which is mg minus kv over 3m, as we have been asked to do. All right, for the second part. They are asking to show that when the time is 3m on k ln2, then the velocity of the larger mass is gm on 2k. Apparently, we need to use the first speed to find an expression for velocity, and then substitute this value for time to end up with this expression for velocity. So this is the result from part 1. We need to get an expression for velocity. So flip both sides, you get dt on dv is equal to 3m on gm mg minus kv. Then integrate both sides. To avoid the problem of having a c, start from 0 to t and start from 0 to v. So the limits are 0 to v because the initial velocity was 0 and the final velocity can be any velocity v. So derivative of t with respect to v is that. So it means that t is equal to integral of that. Okay, if you integrate that, we can take 3m out. This 3m as a constant can go out. We end up with dv over mg minus kv. And if I can make the top, the derivative of the denominator, then I can use the log as my answer. So to do that, I need to have a derivative of the denominator, which is minus k at the numerator. But to balance it out, I got to divide also by minus k, and because minus k is a constant value, I can take it out. All right, so minus 3m on k, and then the integral here is ln mg minus kv from 0 to v. Now replace this with v, which you're going to get the same thing, and replace it with 0, which kv will go away and end up with ln mg. Now you got two ln's subtracted. You can write it as a ln of a fraction. So that becomes ln of mg minus kv over mg. So they are asking us to find the value of v when t is that much. So I can replace t at this stage with that value, or you could make v the subject, then replace it, but this is a bit quicker if you replace t at this stage without actually working out a general expression for v and find the v value for this specific time. Alright, so t is that much, put it here, and then 3m on k cancels from both sides, only this is negative, so we should add a negative on this side, minus ln2. And I take this minus 1 inside to become a power, so 2 to the minus 1, which is basically half. Now I can drop ln's from both sides, and I get half is equal to mg minus kv on mg. And from here is some basic algebra, cross multiply, mg is equal to 2mg minus 2kv, bring 2kv to the other side, this mg to the right hand side, and you get 2mg minus mg equal to mg, and from this v is equal to mg over 2k as we have been asked to prove. Thank you very much for your attention.